So say someone's not been on LinkedIn today, they log in tonight.
Yeah.
First thing they'll see is this live, because if they've attended, it'll be like a reminder to go watch it. So that's quite good as well. Cool. I'm going to hit the go live button now, and then let's see how we go on. Just bear with me a second. There'll be an echo.
It's like being on the Jonathan Ross show. Believe me, we've only got about 3 viewers.
Okay, cool. We've just gone live now, so I will kick off and say welcome everybody. Happy Friday. Welcome to Once Upon a Time in London. My name is Harry Nidger, one of your co-hosts. I am delighted to have lots of people with me here today. I've got Jan, co-host. Jan, how's it going?
Good, thank you.
Yeah, all good.
And if everyone remembers me, my name's Jan Kodabash, work for Universal Technology Solutions, co-host with Harry on a couple of shows.
Yeah, we've done quite a few now. This one's going to be quite an interesting one as well. We've also got several guests with us. Dan, how you doing?
I'm great, thanks, Harry. Yeah, I'm good.
Could you do a little intro for everybody?
Yeah, of course. Yeah. So I work at Cisco, so I'm a technical solutions architect. I'm responsible for ultra latency, so driving the innovation and products in this segment.
Amazing. Dino, how's it going?
Yeah, good. Okay. So well, my second show with you guys. So I'm a network engineer. I mean, currently I'm a man of leisure. So just tinkering with cars and things like that. That's why I sent Jan a photo of me in a boiler suit just before this, because he was saying, like, have you had a shower yet and shave?
We got you.
Smart, so.
Yeah, but I've worked with Jan for a long time, so since 2004. So I've definitely heard worse.
and we've got him back only because he's the cheapest. Yeah,
exactly. Yeah. I can do it cheaper.
Good stuff. Sanjay, can you introduce yourself to us, please?
Hi, Sanjay. I work at Jefferies. I'm on the application space in the financial technology area, and I really work with Jan a lot, so we work very well together.
Amazing. Thank you, Sanjay. Sanjay's actually joined from the car, so that's our first guest that's actually moving on the show. It's pretty cool. And then finally, we've got Kapesh. Kapesh, can you introduce yourself?
Hey, guy. Sure. Hey, good morning. Good evening. Basically, I'm Kalpesh. This is my first show again with Jan. I work a lot with him. I work in DevOps space, so happy to learn the new things with you guys.
Amazing. Crazy. So, with the format of the show, if you've been before, you'll know that we cover lots of different topics and try and give a high level overview so that, at least everyone can get an understanding. And then we tend to go a little bit deeper, talk about challenges, real life scenarios. But before we talk about low latency, which is going to be the main topic today, we also tend to talk about latest trends and news. I tend to bring something to the table. I've been looking at AI. Obviously, ChatGPT is very much in the news, and how it can, do your exams for you and pass all your grades, and, you don't have to go to school anymore. But I've been looking a bit deeper at other AI tools as well. And one that caught my eye is this WriteSonic website, which is completely free. You can go on there and you can type in a question and it will write you a 1,200-word article pretty much instantly. So I was tempted to write in there, give me a high-level overview of low latency in the in trading and, high trading environments. And I was tempted to see what that 1,200-word article would look like versus what we're about to talk about now for the next 30 minutes. So it's really interesting to me how you've got all these tools coming up, which is a new resource for everyone. And I wanted to get the views of everyone in the room of what they were thinking. What do they think about this? Is it good? Is it bad? Is it interesting? What do you see that's going to happen? Jan, you go first. Tell me what you think.
Well, it's definitely useful for, I wish I had it when I was at college. Yeah, I'd definitely be using something like that. And but I do think there's different levels of it, and depends on what kind of response you're looking to get back. Yeah. If you're looking just to get a response back, and again, a lot of these are down to how much information you put in there, and how detailed you are with the question you're asking. But ultimately, if you're a type of person that just goes to a book, even when we used to, the old days where we used to look for information in books, generally we would go either to a whiteboard or test to, really validate that. So I don't know if it's going to be like just taking that for face value and saying, yeah, I've got the answer. But if that's what you want, then maybe it satisfies it, you know.
It's a good point, actually. And I think, what do you think, Dan? Is it, how do we test the content in these tools that's coming out? How does that work from your perspective, do you think?
Well, as Jan said a second ago, it's all about the information that you are able to feed into it. So, if you take ChatGPT, for instance, the data is nearly 2 years old. I know the libraries are constantly being updated, but with these tools and as they're moving forward, we need to either come up with a way that we've got a validated way that we've got an actual product that can do this. So maybe like a vendor comparer.ai or something like that.
Sounds good.
Each vendor decides that they input their own information, so they've got a credible source, or whether or not that's done by the third party, I don't know.
Yeah, it's interesting, actually. There's another tool I saw, which was another AI tool where a vendor or any company can put all of their information into an AI tool, and then it becomes their library and it will pull it out. So that, I think potentially, yeah, your thought on vendors having a resource for their own information could be quite interesting. That's cool. Dino, any thoughts on this? Have you seen this stuff?
I haven't, I must say, but it's like Jan was saying, I mean, when I was at uni, it would have been nice to have this, but I guess, nowadays, with working and everything else, like Jan was saying previously, you're going to get found out. I mean, if you don't do your own work and research and validation, you're going to get found out. But when you're at uni, there's subjects you may not like, and you're kind of like, what, I just want to just get the thing done. So from that perspective, I kind of like say, that can be useful. I mean, because the reality is that you're not going to like all your subjects. Sometimes you think, what, I really like this one, I just need to pass this, and in a way, I don't know, I kind of like see it as being, well, it's a useful tool. That's how kind of like I see it in that respect. But I must say, I've not tried them, to be honest. Yeah.
Fair enough. And finally, Sanjay, have you used any AI tools? Anything interesting from your perspective on the subject?
We do talk about it, we do look at it, we don't. Personally, it's my personal opinion, is it's all about the data, what you feed into it, and we are making decisions based on that blindly. But what about the data which is not there, or we miss data? Because there's always a bias in the capture to the data. At the end of it, what are we getting out of it? Because when we literally look at a problem and try to visualize the data, we always look at things which are not there. And I'm not too sure if AI would really be able to capture that. So it's an interesting thing to work with. And essentially, we are definitely looking at it at this moment, but I don't think we have ever used much of it in production on our side yet.
Fair enough. And finally, Kapesh, any thoughts on what we just said and what's just been discussed?
So from my perspective, basically, I come into the picture when Sanjay and Jan implements the things up, because I'm from the operations end. So I rely more on those guys than anything else at this point of time.
Fair enough. That makes a lot of sense. I think from just to close off on that topic, I mean, I think from what I can see, the AI tools are just going to get smarter and smarter. The amount of data inputs, they're working on the next version of ChatGPT. And if you were to look at it in a size, the first version's a dot, right, in terms of data input. The next version's like a massive big ball. So the amount of data inputs coming in are going to be a lot more, millions of times more. So I can only imagine it getting smarter and smarter. So let's see. We're early, but it could be quite interesting. Moving on, in terms of the main topic of today, low latency, I was hoping someone in the room could give us a high-level overview to kick off with, just because not everybody might not know what it is listening. So, Dan, can we come to you for that, potentially?
Yeah, of course. Yeah, no worries. So I guess we probably should start with what is low latency. Low latency is minimizing the length of time it takes to perform an action or a function. So there's a number of different applications for that. I think one of the ones that we're probably going to talk about mainly here today is probably in its use within trading. And the use within trading is essentially to reduce the length of time it takes for orders to travel to the market and information to be disseminated from a market to participants who want to trade. And what that does is allows customers to make more money, essentially, because you can exploit technology advantages. I guess that's probably the best way that I could sum it up.
Yeah.
What do you think, Jen?
Yeah, no, definitely. One of the things that I thought this would be quite interesting is, although we've just talked about it from maybe just a speed perspective, there are a lot of components that are built on an infrastructure to get you that low latency, and not just achieving it, but measuring it as well, and reporting on it. So we're not going to touch on everything today. Maybe we'll have a few shows on it, but it's definitely a very key area for a lot of trading and investment banking organizations. So I mean, we've got Sanjay who's on here. Maybe he can start us off maybe from, you know, what it is an organization looks at and where they'd like to be. Sanjay, what, from a latency perspective, in that you actually work in that space, what is it that you actually look for in you know, your day-to-day operations?
So to continue with the concept of the trading part, so we build algorithms for clients, and we are essentially trading for the client. So the algorithms primarily takes a lot of inputs, both client and the market data and time and the market state primarily. So if you really look at it from that perspective, we are getting all that information from the markets, multiple of them, especially since the markets are so fragmented. We are trying to make sense of all that data based on the client input. We are trying to make a trading decision which needs to impact the same market from which we were getting the data. Now, when we make the decision, the only information we have is what is available to us, and we want the decision to be made to be very quickly reflected into the market book, because there is a time component to that. And that's what I consider low latency. The amount of time it takes for the market information to reach to the trading system, as well as the decision made goes back to the trading system for the impact. If there is any delay, basically we are trading blind. We are trading incorrect. We are trading on the information which is incorrectly provided. And what we are trying to achieve is to minimize that time which is taken on every step, including the application. And that's what low latency. It's a whole universe. It's not one component. And network is one component. Applications, everything adds to that. That's how I consider low latency.
Definitely. Thanks for that, Kalpesh. I think, you know, just going back to what we were saying there, all of those different components play a key part in it. And sometimes you'll find it's a small section area of a business, but it's probably one of the most critical, and the area that has so many different components, you know, confined to a small subsection of the business, but still so critical. So I thought it would be very interesting, because generally in some organizations, the enterprise itself is the larger piece. You know, it's globally diverse. You know, you've got solutions that, you know, spread right across globally. They may not have that much insight into this type of complex environment. So this is an opportunity for us today to discuss some of those components, and we'll take it step by step, because there are quite a few. We might not reach all of them today, but maybe what we can start with, and Dino, I'll try and bring you in here. Looking at it from a latency perspective, I mean, and Dan will expand on it.
Yeah.
How did it first kind of come to you? When did you first get exposed to it? And you know, what were we doing with it?
Yeah, I mean, as I mentioned, it was, you know, it feels like a lifetime ago. So it was 2008 that, you know, this particular exchange wanted to have, you know, what they call hosting or co-location. So at the time, as you mentioned before, Jan, is about, you know, what kit do we have and how we can shave latency, and literally going through, we got load balancer. What is the latency through that load balancer? This, you know, microseconds. What about the switches? And going down and then see what we can shave off. And then after that, sort of like talking to various clients, what do they want? I mean, this is back in 2008. I think some were asking for 10 gig, but then, it's that whole cost of delivering that service, because as much as there were demands, we didn't know, how many clients we will get, and literally we had the whole floor, cabinets and everything else, and again, then selecting the kit and then talking to the customers, and also some of these customers were more advanced than us. They were asking.
What were they asking? What kind of stuff were they asking for?
Oh, but they were asking specific question in terms of even the kit that you're going to have, the actual, if it was Cisco, what supervisor, say it was 6500, what sub do you use, what line card do you use, and all those type of things. And then also some of them asking about fairness, and can we get on port 1? If we buy it now, can we be on port 1? So again, they understand, what is the difference between port 1 and port 24, and all these type of things. And through that, and working with the vendors, then, I also learned, I think, for example, I think because this is a long time ago, so I think it's, it's no longer relevant, but, we end up going with 6500. And I think the latency through there was around about, I can't remember, about 4 or 5 micro, which was slower than other vendors. However, when we look at fairness, I think the fairness for multicast replication, it was, I think, max on any port, it was 2.5 micro. It was any port. Other vendors may say, wow, we can do 2 micro across our switches. But then when you look at the multicast replication, at first it looks to be better, but up to a certain point, whatever number of blades, that's it. It just end up being 20 micro, 30 micro. So those are the kind of things. And we had to then figure out how we can test that. And in those days it was quite difficult because, like 10 gigs, for example, 10 gig taps were really expensive. I mean, and you would only get like 2 ports for like, I don't know, like 15, 30 grand, I mean, it's crazy money, and it's so how do we do that? And then, and I think we use InfiniStream to test, and we would connect multiple ports into the InfiniStream, and it was hardware timestamp, and we would see the difference, but moving in ports and see what the difference between the multicast, because multicast was kind of like our bread and butter, really, being an exchange, and literally it was just figuring that out and making sure the customers is aware that we're also looking at that. Some of them were asking cable length, is your cable length all the same, and then also the other, some of the customers were saying that, look, we want our cabinet, that the door is basically like, so they don't want people to be able to peek through that door to see what they have. So we had to find like doors that is really, really difficult for you to actually, you might see lights, but you don't know what the kit, is. Those are the kind of things, and it was quite challenging. And I mean, I work with another person, and it's that he's a friend of Jen and I. And the funny thing is that he's retired now. Very lucky of him. But he said that out of his time at the exchange, doing hosting with me was the most stressful thing. Maybe that was because he was working with me, but I think I don't know. But that was honestly, that was really intense. Literally, it was 2 of us. Like we had to deal with everything. And to me, it's the funny thing. Even every morning, we had to justify how we didn't have time to do everything. And we couldn't get resource, and it was intense. I mean, it was definitely quite intense, and dealing with customers and their questions, because I think they were more advanced than us, because they were spending a lot more money doing this type of stuff.
So I can see Harry looking at this and thinking, well, but I think Harry, this is what Dino's explaining here, and for some of the people in the audience that may not have grasped everything, it was more about what we're talking about from a network perspective at the time is shaving off the time it takes to actually switch frames or packets through infrastructure to get it there quicker at the time. That was one of the main things we were trying to do from our perspective, from a networking perspective at that time. And there's multiple ways of actually trying to do that. And
Actually, like actually listening to you guys, I was just absorbing it all. It feels like a Formula One race. Like
Harry, I wish it was as glamorous.
No, like if you look at it at a high level, you're obviously trying to get it's like think about a race car trying to get around the track, right? And you think about Formula One, they're always shaving seconds. It's like the aerodynamics of the bodywork, it's the engine, the tires, it's all these little micro things. And how you talked about the apps, the infrastructure, all the different components that make up the packets. Like I think it's almost like it feels to me that then some banks and institutions will be in the Formula One race, and then some ones won't even know there's a race even existing. So that's quite interesting. How in my mind it was circulating.
You're really, you hit the nail on the head, Harry. I often use that as an analogy to explain to people what ultra low latency usually means, because you spend a lot of money doing R&D to develop your car infrastructure in order to race to win the trophy. Win the trophy in high frequency trading is making the money. So yeah,
interesting.
Good analogy.
Dan, so Dino was talking about microseconds at that, back in those days, but now maybe we could maybe touch on some of that evolution. It's been maintained. People are still looking at a competitive advantage. What is it? What's the race looking like nowadays?
Yeah, well, that's a good question. So for anyone who's watching, I think a really good book to get an understanding of what's going on inside of the low latency world at quite high level would probably be Flash Boys by Michael Lewis. If you haven't already read that, it gives you a very good foundation of what it really means. And that was around a similar time, right? 2007, 2008.
Yeah.
I know that you obviously had those IBM blades that you were talking about earlier on, probably 2009, 2010. And there's been significant progression over the last 10 years or 12 years or so since all these technologies have been coming out. So there's been significant developments inside of both Cisco, Arista, Mellanox, etc. There's loads of different switches out there now. From Cisco perspective, the 3548 it's still a beast. It's a fastest ASIC based switch in the market. So we're talking about nanoseconds now, though. So we're trying to get as low as possible. So I heard you were talking about numbers about 2.5 microseconds. So
that was the first, and then basically when I was at the exchange, we basically went through 3 iterations. So yourself, and then another vendor start with J, and then it came back to yourself again, and because then at that point when the first the Nexus 3K, I can't remember the particular model, it was I think the replication was around about the 100 nano, if I remember correctly.
And do you know what, on that point that you say there, Dino, I think it's important, we were talking about it just before, the life cycle was of those interchangeable, trying to get the next best was quite short.
It was quite short, and then also the other thing I think sometimes you forget is that as you change that, you need to also migrate your customers, and you have to migrate all of them at the same time. To be fair, you know what I mean? You can't then say like, well, I've got now hosting is 10 gig, but we can't migrate everyone at the same time. So there's another challenge as well there.
Yeah, an operational problem, right?
Yeah.
To do that. Yeah. So and I think that the key there, obviously, Dino, is that the technology is constantly evolving. Yeah. So 2012 is when that switch initially came out, and there've been so many developments since then. So from Cisco now we've got the 3550 product lineup, which was previously Exablaze. You also, takes into account layer 1 technologies. So if you're not familiar with layer 1 technologies, it's effectively mapping physical light wires together to get as fast latency as possible. So we're not even doing any packet inspection, and with that you can get latencies as low as 2 to 4 nanoseconds. So it's ridiculous of how far we've come.
So on that one, Dan, is that being used more for when people are sending like just one-way traffic, or are you seeing that type of switch use just to replace standard unicast based TCP service traffic?
So actually seeing it do both. Seeing it do both. So typically you'd use a layer 1 switch to take a market data feed, maybe from the LSE or another exchange. You would then forward that, take that into the layer 1 switch, take a copy, and then replicate it out in 4 nanoseconds to all of your trading hosts. So your trading hosts have now received that market data as nearly as quickly as possible, literally speed of light going through a single chip on a device. So that I guess that handles the market data piece, but the actual order entry piece, the piece you mentioned about a minute ago, Jan, is so that's the unicast flow. So that has to go via a multiplexer, which is an FPGA or a piece of equipment that's been programmed to run through, or basically round robin, a bunch of inputs to put light onto the wire, essentially.
Right.
And by doing so, you can get latencies down into sub 40 nanoseconds. There's been dramatic improvements as FPGA software and firmware has been developed to improve that even further. So I think when the technology first was starting to be adopted by customers, the FPGA muxing capabilities or the latency of that was around 110, 120 nanoseconds, and it's slowly just come down all the way until the point where it's been optimized beyond comparison.
So you mentioned there the FPGA on the new range of switches. That's a new component from a network, or some networking operations team or engineers may not see that or operate FPGA. Where are you seeing that actually, that function now? Is that sitting with it? What are the networks teams having to do now to understand that technology or to operate it for people like Sanjay and so on?
Yeah, so if you're talking about operating and using that technology that already exists, then it typically would sit within the networking team. You probably see on like job boards and things like that, low latency network engineer or something along those lines, quite specialist skill set. You wouldn't usually see that inside of the enterprise market. So you kind of get a lot of knowledge over time in the marketplace. I think that there is another element that we haven't really talked about yet, is the actual reconfigurable component of the FPGA as well. So these FPGAs field programmable gate arrays, so they can actually be reprogrammed. So you could have someone in your team or a part of your business who could actually take the hardware and develop their own logic on top to do their own development. So all of the products as part of the 3550 lineup and the SmartNIC lineup at Cisco, we all support full reprogramming of the hardware. So you can change it however you want or need to match your business requirements. And by doing so, you've unlocked a lot of power for users.
Interesting. Well, we've really hit on now. Actually, maybe it would go back to Sanjay. You've heard quite a bit now of some of the evolution. Some of those times, Sanjay, nanos or even the FPGA side of things. Can you see yourself, leveraging some of those, capabilities going forward?
It's a question of a want and a need, right?
Yeah.
Definitely very interesting, and we can definitely essentially start exploring newer solutions with all the advancements. Being able to run an application on a switch directly on the same hardware, amazing idea. Right now, do we have a need for that? I do not believe we do from our business perspective, but I'm quite sure there are people who are looking at that, especially at the market making side of the thing. So remember, it's always a lockstep thing, right? As the thing changes, we need to get more protective of our clients, and we need to adjust for the market behavior. So we are continuously watching, and we will adjust very quickly as the need. But at this moment, I don't see that as a problem within the space I am in.
Okay. All right. Thanks. So, Dan, what's interesting is we talk about these numbers, and we talk about being first to the market, but it's just as important to be able to measure, because it's fine saying, actually maybe someone's just gone to a data sheet and switch. How are we? There's where we've looked at it previously. It's always been down to actually going through a set of design principles for your measurement tools. So looking at it from a paper-based technology, looking at them and comparing them, punch list, whatever you want to do, and then actually bring it in and actually testing it. That opens up a whole different set of criteria. It needs a whole set of new tools, and in fact sometimes the cost of your measurement and reporting is significant, isn't it?
Yeah. So that piece is an element of its own. So just doing the performance testing alone on these types of boxes can take weeks, months, sometimes even years for some businesses to adopt these appliances, because they've got to go through a number of rigorous testing frameworks. RFC testing, performance testing, so 2544 testing, very important. Making sure that it meets the demand and needs of full line rate, testing the latency of the device, comparing that to what the vendor says and how that's going to match up. And
can I ask you on that 2544 test, that was set out, and it serves as a very good baseline for other, even if you want to test anything, has that evolved at all, or does that still stand good ground for testing some of these tools?
It still stands good ground. So it's still being used today. There's a couple of additional RFCs as well now. There's been some additional functionalities been added to the 2544 over time. You can add burst rates into it as well now to see how packet buffers and stuff like that will behave. So there's the unit testing that you talked about in terms of the measurement, but then there's also the actual trade performance. When you take a server, connect it up to a piece of hardware, whether or not that's going to be an ASIC based NIC or an FPGA NIC or a software trading instance, connected that through to the network, testing cable latencies, testing the length of time it takes to get to the exchange, fairness. Dino, you talked about that a moment ago, about seeing how far away you are from different ports on different latencies. So there's something that we've been tackling recently with the 3550T is trying to get sub 1 nanosecond deviation for multicast fairness.
It's crazy, isn't it?
It's very interesting because layer 1, so it might sound crazy, but layer 1 fan out latency, so between some of the output ports, 2.5 nanoseconds is too much.
Yeah.
And we're able to now measure that with other functions such as I don't know if you're familiar with White Rabbit.
Yep,
Yes.
Rabbit.
Yep. So I was going to actually come on to that. Is so just the measuring tools themselves, obviously their reporting is actually aligning your reporting with some very good precision timing. And I'm not sure if you've looked at some of the previous shows. We had Hoptroff on, and we look at MiFID, well, the compliance part. A lot of these environments we're talking about come under some financial requirement regulations. And one of the components of that testing of precision time is White Rabbit, like you mentioned, having all of these products integrate with those. Now, before you used to have these tools outside of it. Are we integrating that into our switches now so that our switches are accurately, for example, White Rabbit, are Cisco looking at integrating their switch with White Rabbit rather than consuming P2P, for example?
Yeah, so we're offering all connectivity mechanisms. So we're working with White Rabbit vendors to deploy that type of infrastructure and code into our devices. We will also be offering P2P as well as NTP. The new 3550T actually has an oscillator inside of it, so you can actually use that to become a P2P grandmaster or a very high accuracy P2P boundary clock. So you could deploy them in your network. If you lost your master, you'd stay within compliance. Whereas before, with some of the older switches or other vendor switches, you weren't able to do that in the data path. So it's about I guess, trying to match the market needs or demands.
Yep. No, that's I guess a conversation on its own when we talk about measurement, especially timing on that. Just on that, for those who thinking, okay, well, White Rabbit and P2P, there is a difference in like sub nanosecond precision that White Rabbit does. I think a MiFID compliance isn't a requirement for that, but some places are looking at getting sub nanosecond precision.
Exactly, yeah. So, MiFID and FINRA requirements, in my eyes, they're good. I think they're good, but I think they're pretty lax in comparison to probably what we're able to achieve with the technology. So, for instance, RTS 25 for MiFID 2 is 100 microseconds to UTC. Yeah. Whereas, we're able to do single-digit nanoseconds in some cases, just with PTP, which is, significantly lower than that. I think one of the reasons that time precision is so important is when you're matching up time data between destinations or locations. So if I was trying to match up, the length of time it took for me to get pricing off of the LSE versus the New York Stock Exchange, I want that to be as tight as possible so I can look at my trade performance and how things are behaving.
Okay, I mean, I could see us getting close to that time now, but what I would like to say to you, Dan, is that, say, for example, today, and I know this is probably, just I've got a lot of answers to this question, but what platforms, if we were going to choose platforms, firstly, what platforms, if someone's just looking for the lowest latency that Cisco are doing at the moment, what one are they pitching at the moment?
Yeah, so it depends on what level and what app use case you have. So if you were looking at L2, L3 platforms, you'd be looking at either the 3548 XL, which is the latest variant, or there'd be the 3550T, and they both got their unique use cases. The 3550T is the lowest latency box that Cisco has, with the multicast fairness, but the 3548 is ASIC based. So it depends on what you want.
And so, and with that, sometimes one of the next questions we get is, we've got to look at the density of, 10 gig density.
Yeah.
Which one can I get the best, 10 gig density? Yeah.
The form factor is the same on both of them. However, I think the key thing that we need to be looking at for future proofing and looking forward into the future is 25 gig is coming. I think every single person probably on this call probably thinks 25 gig, we've already got that, but in a lot of the markets we don't. There isn't a lot of low latency markets that have that today. I think everyone's been standardized on 10 gig. I think it's almost like commodity trading now with low latency, and I think the ball game will change over the coming years when we introduce more and more 25 gig switches and applications into the market. And
so on that, why are people not looking at going straight to 40 gig and why 25 gig?
Sure. So 40 gig is essentially 4 lanes of 10. 4 lanes of 10, there are a couple of markets that are on it, but you've got some limitations when you come to like single flow sending. 25 gig is really the natural progression, I believe, at least on all the projects that I'm working on so far. That's where I'm seeing it. Telcos as well. So telcos aren't wanting to put 40 gig lines into the ground. They're wanting to put the 100 gig infrastructure into the ground. So all the latest low latency circuits across the globe, they're all going to be 100 gig, I'd expect, as a standard. So there needs to be infrastructure ready to work with that.
Yeah. And is it and I guess with the 25 gig, the form factor stays the same as 10 gig, which helps on that.
Yeah, it very much stays similar. One of the other reasons for 40 gig as well is there's serialization delays and things like that come into play when doing speed changes and stuff like that.
Well, we didn't even come into serialization delay on this whole conversation, and you mentioned it right at the end. But look, look, this definitely, I mean, we've already run work 5 minutes over. Has anyone, I mean, maybe we just go around. Dino, have you got any like closing words on this?
Like I said, no, probably not from me, really. You know, I'm like I said, I'm the dinosaurs of of this. Really, it's just it's like the 6500. Which is obviously very special to me, Jan.
Yeah, well, listen, you need to know where you came from before you can get to where you want to be. So and Sanjay, thanks for joining. But is there anything you want to say or close with?
I'm the one who is learning the most, so I really appreciate that, and thank you all for this. This is really wonderful. I'm glad to be part of this. Thank you.
Excellent. So, okay, I mean, Dan, great. Thank you so much for this. I think we didn't get to cover everything, but definitely let's see what outcomes we have or what comments we have, and we should get together again and maybe go into a bit more detail, specific maybe on the measurement side as well.
Yeah, I think there's a lot of topics to talk about. So yeah.
Harry.
Awesome. No, thanks guys. Thanks everybody for your contributions today to the low latency. I've learned a load. I mean, when I think about it in F1 terms, it makes me more excited. I'll be honest with you. It gets me more, when I think about, if we could turn the F1 cars into livery, one's UBS, all the banks on F1 cars, right? They're all racing around. I think that'd be good views on YouTube, actually, to be fair. But no, it's all good. No, thanks everybody for the chat. Look forward to next week, every Friday, 1 o'clock, different topics. Once upon a time in London. Hopefully see you next time. Thanks, everyone.
Thank you. Thanks, everyone.
Thank you.
Thank you.
Cheers.
Bye.